7.5. And this is not a whole number. This is not a whole number. So we round up to get C equal 8. Always round up. Always round up. Round up. Even 7.2 also get 8. Even 7.1, you still round up, get 8. That's C equal 8. So the eighth data value, and find out 8 data. And put in order, the data sorted in order, counted 1, 2, 3, 4, 5, 6, 7, 8. The 8 data is 97. So you have ordered the data. And then use this count is equal n total how many data, 10 data, times by percentile, 75% is put in fraction is 75 over 100. Time together get 7.5. If it is not a whole number, you always round up, get 8. Even you got is 7.4, 7.3, still round up, get 8. And then counted the 8th data value. 1, 2, 3, 4, 5, 6, 7, 8 is 97. So 75th percentile, the corresponding score is 97. The score 97 in the class is on the 75th percentile. So, and this formula is in here. Finding a value corresponding to a given percentile formula count C is equal n times P over 100. That's a formula that we learn from. Use this formula to do. B, ask you what score corresponds to the 80th percentile. 80th percentile. So it's also still use this formula. C equal n. N is 10 times P over 100. Here is 80 percentile is 80 over 100. You got 8. If you got the whole number, we look at the value in the C and the C plus 1 positions. Since C is 8, plus 1 is 9, so is the 8th and the 9th value. And you're looking for 8th value. It's 1, 2, 3, 4, 5, 6, 7, 8 is 97. Add 1 is 9, 99. So the 8th value is 97. And the 9th value, C add 1, 8 add 1 is 9. 9th value is 99. Add together the midpoint. 97 add 99 is 196. Divided by 2 is 98. Is between 97 and 99, right in the middle. Is 98. So 80th percentile, the score is 98. 98 is not in this list, but that position is 80th percentile, is 98. So here, if you do n times percentile, if you got decimal number, not whole number, you always round up and then you count it and got whole number, then you counted which one you got the answer. Now, if you do n times percentile, if you got whole number, then you have to find out that whole number and the next one. And then the two two numbers, two score, add together, two data, add together, divided by 2. And is right between the two, C and the C plus 1 data. And add together, divided by 2. If a not whole number, you always round up and count it, that number. That find the data. If a whole number, you need to find out that whole number and the next one data, and then add together, divided by 2. So is that difference. Next one. What is the percentile rank of 78? Which is this 78? What's this 78? The percentile is which percentile? Which percent? 78 in the whole class, in this 10 number is located at what's percentile of 78? So formula is this: percentile equal number of value below 78, below x is 78, add 0.5 divided by total how many numbers of the value times 100. The formula is here. So equals the number of the values below 78. So you look at here 78. There's 2 number below 78. So it's 2. Add 0.5 over total 10 data, 10 numbers. Divide n is 10. You got 2.5 over 10 times 100. 2.5 over 10. You can cancel this 0. Got 2.5 times 10 is 25. So answer percentile is the 25th percentile. And this also lists on this formula sheet. Formula. Percentile rank of a value x, given x, is equal to the number of values below x, add 0.5 divided by total number of values times by 100. So then next one is construct stand leaf plots. We already talked about this. Talk about, first of all, you put from 10 digits and 10 from 10 position and put the stand, and from 1 position find out those and then put them in order. As we beginning, we talk about this order stand leaf plot. Question 5. Suppose there are 3 exams, exam 1, exam 2, exam 3, in a class. The exam scores as percentages are weighted to calculate the final grade. Suppose a student obtained these scores. Exam 1 get 86 out of 100. Exam 2 get 92 out of 100. Exam 3, we don't know. We are looking for exam 3. So weight. First exam, 30% of final grade. Second exam is 30% of final grade. Third exam is 40%. You can add those together. 30 add 30 is 60, add 40 is 100%. Total 100%. So if the final grade is a 91.8, ask you, what is the score percentage did the students obtain on exam 3? Exam 3 score, how much? So we can assume it is X. And we will use weighted mean. Weighted mean formula is the summation of weight times x divided the total of the weight, summation of the weight. That's the weighted mean is going to be 91.8 final grade. I use this formula. So that's weighted mean is the final grade. Summation of the weight. So its weight is 30%, put the decimal is 0.3 times 86 plus the weight. 30% put decimal is 0.3. 30% put decimal, you 0.30 is 30 here. Move decimal to the left 2 position, get 0.30, drop percent sign. 0.30 is the same as 0.3. Same. You can drop this 0. And the 40% is 0.4 times x. We can assume this is x. X divided by total weight is 0.3 add 0.3 add 0.4 is actually is just 1. Divided by 1 is, so actually is just this 86 times 30%, 92 times 30%, x times 40%, add together, total should be 91.8. Should be equal 91.8. That's the final grade. It's a weighted mean. So it's use calculator. You can figure out 0.3 times 86, add 0.3 times 92 is 53.4. Add 0.4 times x should be equal 91.8. And get this equation. Then you minus 53.4 on left and the right. This cancel. Get 0.4x equal 91 minus 8.8 minus 53.4. You got 38.4. And then both sides divided by 0.4. So 38.4 divided by 0.4, you can use calculator. You got, it's 96. So if exam 3, you got 96. Then next question, explain the difference between a statistic and a parameter. So a statistic is a measure obtained from sample. A parameter is a measure obtained from all the subjects in a population. So statistics, sample, parameter, population. For example, like a mean in population, mu is a parameter of population. For the statistics, for the sample mean, we use x bar. X bar is sample mean, is a statistic for sample. Population mean, mu, is a parameter of population. Another one, like standard deviation, use sigma. Sigma is a parameter, is a measure we call parameter of population. So this mean and sigma, those are a measure. Those we call parameter. For measure of population, we call parameter. The measure of sample, we call statistic. So like x bar, like standard deviation, sample standard deviation, S, those are statistic. We call statistic of sample. So the statistic S corresponding with sample S. Parameter is P corresponding with population P. Next, z-score. Z-score formula is z equal x minus mean over s standard deviation, is away from mean. Given x minus mean is difference between mean, those are sample, divided by standard deviation. Get how many standard deviation away from mean. So suppose data is 40, x is 40, mean is 50, sample mean. Standard deviation is 5.5. Calculate z-score. So z-score formula is x minus x bar over s. X is given 40 minus 50. And the difference is negative 10. 40 minus 50 is negative 10. Divided by standard deviation is 5.5. Negative 10 divided by 5.5, you got negative 1.81. 81 repeating, and just put negative 1.81. This means 1.81 below the mean. This normal distribution. Normal distribution. Here is sample mean is given. It's 50. Standard deviation is 5.5. So here 40 is x. X is 40. 40. So the below the mean 50, away from mean is negative 10, divided by one standard deviation is 5.5. Then you will get is 1.81 and negative. Negative means below the mean. 1.81 standard deviation below the mean is this x. One standard deviation is 5.5. Then now is 10. 10 divided by 5.5, you got is 1.81 standard deviation. And since it's negative, it's below the mean. That's a z-score. Next one, the z-score formula is also over here. Here is z-score equal. For population is x minus mean over standard deviation, mu over sigma. For the sample is x minus x bar over s. That's z-score formula. Then next one, calculate the coefficient of variation. Coefficient of variation we write is CVAR. Formula is equal standard deviation S over mean, sample mean, times 100%. So here standard deviation is 5.5. Mean is 50 divided times by 100%. So it's 11%. You do 5.5 times 100, it's going to be 550 divided by 50, and you got 11 with percent sign. This is we call coefficient of variation. And the formula is also over here. Coefficient of variation formula is S over X bar times 100%. Or for this is for sample. For population is sigma, population standard deviation over population mean times 100%. That's coefficient of variation. And the next one, question 8. Suppose the mean of the number of sales of the cars over a 3-month period is 85. So this is what we call X bar, 85. And the standard deviation is 5. So this is S, is 5 for the car sales. Car sales. The mean of commission, salesperson commission, mean, and this also X bar. And the standard deviation, this is S, is 770. Calculate the coefficient of variation for the number of sales. So we calculate CVAR for sales. And the coefficient of variation for the commissions. So we calculate commissions coefficient of variation. Then state which variable has more variation. The higher one has more variation. So for the sales, standard deviation is 5, S5 over the mean is 85 times 100%. And you do 500 divided by 85, got 5.882%. Rounded to 1 decimal digits, round up, get 5.9%. That's the coefficient of variance of sales. The number of cars sold. Commission, salesperson's commission, is coefficient of variance is equal to S. Standard deviation is 770 over the sample mean is 5,220 times by 100%. So you do 77000 divided by 5220, we got 14.751. Rounded to 1 decimal digits, round up, 5, more than 5, or 5, round up is 14.8%. Compare the 2 percentage. Commission is higher than sales. So we answer commission have more variation than sales. Since the coefficient of variation for the commission is higher. The next question, find the z-score for each test and state which is higher. Which score is higher? Test A score is 36. The mean is 40. Standard deviation is 5. Test B score is 90. Standard deviation X bar is 100. Standard deviation is 10. Mean is 100. Sample mean X bar. Sample standard deviation S is 10. You look at numbers, 90 is more than 36. So you probably answer test B score is higher. But you cannot compare like this because they have different mean. So we have to standardize, find out the z-score. So z-score formula is the number, the value, minus sample mean divided by standard deviation divided by S. So for test A, z-score, for test A, we put ZA equal. The score is 36, X is 36 minus mean is 40 divided by 5. Standard deviation is 5. So 36 minus 40 is a negative 4 divided by 5. Divided, it's a negative 0.8. So for this one, if you draw, here is the mean. Then you draw this, is going to be, mean is 40, and then it's going to be 0.8. Here is a 36, is 0.8 standard deviation below the mean. Now corresponding, the other one, here is mean. Mean is 100. This is A test. This is B test. 100. Then the score is 90. 90 minus 100 is negative 10. Divided by 10 is negative 1. Is 1 standard deviation. This is a 0.8 standard deviation. This is 1 standard deviation below the mean. It's 90. 90. So this far away from mean is 1 standard deviation. This away from mean is 0.8 standard deviation. So in negative 0.8 is greater than negative 1. Negative 0.8 is more than negative 1.0. More than. Which one is higher? So this, because this closer to the mean, this is further away from mean. So the higher one, negative number, negative 0.8 is greater than negative 1.0. So the scores for test A is relatively higher than the score for test B. Choose the higher one. Choose the larger one. So the test A is higher. But if you look at the actual number, 36 is less than test B, 90. But you standardize it, you get Z score, but relatively higher than. But test A is higher. You have to standardize this because they have different mean. Which one is closer to the mean is higher. Then the next question 10. Question 10. Identify the quartiles. Outliers. Identify the outliers in the data below. Use the procedure involving the interquartile range. We have to figure out interquartile range. Identify which data is outlier. What is the outlier? Outlier is the number, is the data is not consistent with the other data. Like alien, like the number is too small or too large, too below it, too low or too high. It's not consistent with those numbers. Like this, between 2 and 10 is 8. Add 8. 2 add 8 is 10. Add 4. Add 1. Add 1. Add 1. Add 0. Add 4. Then this is from 21 to 30 is add 9. And you probably, this is add 8. You don't know which one. This is add 9. And those is more closer to each other. They just add 1, add 1, add 1, add 1, add 0, add 4. But this is add 9. This is add 8. But you don't, how to determine? Probably this 2 is not very consistently add the number. And that's we call like alien is we call outlier. That will affect, if your score is 2, that affect the average. And then we have to determine which one is outlier. You look at the number, it's hard to determine. There's a formula to determine outlier. The formula is, first of all, we have to put those numbers in order. Since already in order, then we are looking for 5-number summary. What's 5-number summary? Find out the minimum is 2. Find out maximum is 30. Then count 1, 2, 3, 4, 5. From right, 1, 2, 3, 4, 5. The middle one is 16. And this is second quartile, is median. Then from this median, you separate lower half part and the upper half part. In lower half part, have 4 number. You count 1, 2 from left. Count 4 divided by 2 is 2. So 1, 2. From right, 1, 2. And there's 2 middle number. The 2 middle number, 10 add 14 is 24. Divided by 2 is 12. And that's called first quartile. From upper half part also 1, 2 and 1, 2. So there's 2 middle number. The 2 middle number, 17 add 21 is 38. Divided by 2 is 19. So 19 is right between 71 and 17 and 21 is 19. That's called third quartile. So this we call 5-number summary. 1, 2, 3, 4, 5. Minimum, first quartile, second quartile, third quartile, maximum. 5-number summary. And so, what is the interquartile? Interquartile range. Interquartile range is third quartile minus first quartile. Is third quartile is 19. Is this minus 19 minus 10. 19 minus 12. 19 minus 12. Third quartile, 19 minus the first quartile is this interquartile range, which is before we learned this box plot. This is a minimum, this is a first quartile, this is second quartile, this is third quartile. This is a maximum, is this one. Between first quartile and third quartile, subtraction, this range. This we call interquartile range. Interquartile range. And then you do the third quartile minus first quartile. You got 7. That's interquartile range. Use this interquartile range. The formula is below the first quartile, 12. You minus 1.5 off interquartile range. 1.5 times 7. Interquartile range is 7. So it's 12 minus 1.5 times 7 is 10.5 minus got 1.5. So formula is first, this is a formula, first quartile minus 1.5 times interquartile range. The upper one is from third quartile, add 1.5 times interquartile range. So it's above third quartile, 1.5 off interquartile range. Third quartile is 19, add 1.5 times interquartile range is 7. 1.5 times 7 is 10.5. 19 times 10.5 is 29.5. If any data below 1.5 or above 29.5, we call outlier. So the outlier are values that are smaller than 1.5. So we look at those data. Are there any number less than 1.5? No. 2 is more than 1.5. So there's no number less than 1.5. Are there any data larger than 29.5? So to the right. Larger than 29.5 is 30. 30 is larger than 20. Is too low. Lower than 1.5. We call outlier. Or too high. More than 29.5, which is 30 is more than 29.5. So 30 is an outlier. 2 is not outlier because 2 is not lower than 1.5. You have to be lower than 1.5. More than, higher than 29.5. There are two sides to determine outlier. Question 11. This is the last question. Is more complicated. More complicated than the others. We are going to figure out, we call the weighted frequency, variance, and the mean. So this is going to 15 batteries were tested to see how many hours they would last. And here has the frequency. 15 batteries. Find the standard deviation of the sample. This table is a frequency table. This is a class. 1 to 3 hours, 4 to 6, 4, 5, 6 hours, 7 to 9 hours, 10, 11, 12 hours battery have life hours. From 13, 14, 15 hours, from 13 to 15 hours. 3 means 3 battery. The life is tested is hours is between 1 to 3 hours have 3 battery. 4 to 6 hours have 6 battery frequency. Means how many batteries? 7 to 9 has 6 battery. 10 to 12 has 3 batteries. 13 to 15 hours have 2 battery. If you add those together, 3 add 6, add 6, add 3, add 2. Total summation is equal to 15. Summation is 15 batteries. So this question, the N is 15. 15 batteries. Now we are going to use this formula. Find out the standard deviation of this frequency distribution. Variance formula is this. Standard deviation is just variance take square root. So in this formula is N. So now is N is 15. N is 20. I have should be 20. It's not 15. Here is 20. Have 20 batteries. So N is 20. So you add together frequency F 3 add 6 add 6 add 3 add 2 total is 20. N is a summation of frequency equal 20. Equal 20 add together. Here we need to figure out in this formula is N is 20. N is 20 and formula is summation of frequency times xm. Xm is midpoint. So we have to figure out midpoint. This midpoint between 1 and 3 hours, the mid average is 2. 1 add 3 is 4 divided by 2. Average is midpoint is 2. 4 at 6. 4 between 4 and 6. Midpoint is 5. 4 at 6, 10 divided by 2 is 5. 7 at 9 is 16 divided by 2. Midpoint is 8. 10 at 12 is 22 divided by 2. 11 is the midpoint. 13 at 15 is 28 divided by 2 is 14. So those are midpoint of those class for each class. Midpoint for each class. And there has 1, 2, 3, 4, 5 classes. And then frequency is a copy over the table, 36632. Add together is total, n is 20. Then we have to figure out f times xn, because here f times xn we are going to figure out. We also need to figure out x midpoint square and time together. So we need to figure out those for the formula. So f times xm is the two time together. F is great frequency. Xm is the midpoint time together. 3 at time 2 is 6. 6 times 5, 30. 6 times 8 is 48. 3 times 11 is 33. 2 times 14 is 28. Because in the formula, we need to time together. We got 5 times xm. Add together. 6 add 30, add 48, add 33, add 28. Add together. Total 45. That's summation of, which is this part, 145. And in the formula, square. So 145 squared. Put it over here. Subtract from this. N is 20. This one, we need to figure out midpoint square. So 2 square, this is x midpoint square. 2 square is 4. 5 square, 25. 8 square, 64. 11 square, 121. And 14 square, 196. Then we need to figure out f frequency times xm square. So the frequency is this column times xm square. So 3 times 4, 12. 6 times 30. 6 times 25, 150. 6 times 64, 384. 3 times 121, 363. 2 times 196, 392. Then add together. 12 add 150, add 384, add 363, add 392, get 1301. This one is a summation of frequency times midpoint square equal 1301. And put it over here, n is 20, and this is 1301 minus this 145 square over n is 20 times 20 minus 1 is 19. 20 times 19 is 380. And those use calculator. You do 20 times 1301 minus 145 squared. Figure out is 4995. Use calculator. Then use calculator. Divide it. You got 13.14473,684. That's variance. Take square root. Get standard deviation 3.625. And round it is 3.6 is the answer. And this formula also listing on the formula, which is this one. Mean. This is the mean formula. F times midpoint summation divided by how many number is the mean. This is a variance formula we use. So far, those formulas summarized over here. First one is the population mean summation of data divided by how many data. This is a sample mean, x bar equals summation of data over n. For population, use capital N. For sample, use lowercase n. And those are the variance is equal summation of x minus mean quantity squared divided by n. This is x minus x bar. But this for sample divided by n minus 1 is not divided by n, it's divided by n minus 1. For variance is just standard deviation, just variance take square root. And this is a shortcut for variance formula. Shortcut formula is summation of x squared over n minus mean square. So this mean for population, mean for sample. And this is here listing our shortcut formula for the variance, shortcut formula for sample variance and the sample standard deviation. This. And here is the mean and the variance for group data, group frequency distribution. This is a formula we just used. This is weighted mean, weight times W times X summation over summation of weight. And normally denominator equal 100. And this is a coefficient of variance formula. S over mean. Standard deviation over mean times by 100%. That's coefficient of variance. And this is a percentile rank of a value X. Percentile